Good afternoon, everybody. My name is Jason Wampler. I'm the host of another episode of the Rocket Minute. I'm hoping that you're finding this show informative. We're in the beginning phases of several rockets, the construction of which is underway. As per my progress on each show, this is a twin-engine monstrosity. We've kind of been building this. We've got a lot of things we have to do. I need to get some more funding. Hit the like, hit the subscribe, leave a comment. As far as this twin-engine rocket is concerned, we're done with kind of the bottom end, but these motor tube housings are removable. I have to figure out how to put an actual reloadable or rebuildable motor in each of these. I may end up making something on a lathe. Then the loading system, securing system, it shouldn't be that big of a deal. All you want to do is hold the motors into these tubes. And the reason I have them removable is one of two things. I may actually use the reloadable motor system in these tubes, but I'm thinking if I can put actual dry fuel cartridges, whole cartridges with the delay grain and the separation charge, which is basically GoX, double F, or single F, double F, or triple F gunpowder, like smokeless gunpowder, a slow burning delay charge, and also the propellant grain. Then I'm going to show you how to make a core burner rocket motors. I don't like using propellant segments, but maybe we're going to make the whole propellant grain with the separation charge, the delay grain, and the main propellant chamber, the bulkhead, forward bulkhead, and the rear nozzle, and encase those in high pressure, high temperature machinable Garolite tubes, and then just secure them in these tubes somehow. And then when they're spent, take these guys out like so. I need you to see this. There you go. By the way, don't run these in too tight. I lecture you. I should be lecturing myself. This is black nylon. Or it might be ABS. No, it's more like black colored nylon. The ABS has a different smell to it. These are MPT threads. They're designed so that when you run these on, I don't know if you can see a gradual taper. I draw a picture of this. Let me take these glasses out. What a strange studio I have here, but it'll do. The MPT threads, if you can see right here, it's hard to see the gradient, but the MPT threads, they're in this case, it's just designed so this particular motor housing that houses the propellant grain and cartridge, the complete assembly. I'm just kind of making this engineering, working this stuff out as I go along. This unit right here is a rebuildable motor system with this is a female end, this is a male end. The threads are simply designed so that you can just run this back on and load this engine like that. It's fairly stiff. But it's removable. This is basically a motor loading system. So I'm thinking I should be using single-use phenolic jacketed or even craft paper jacketed cartridges that you burn them out, you throw them away, but you reload this system. So this is a reloadable motor system. But what I was saying before, because I didn't want to make anything elaborate, I don't want to make molds and design parts. I just want to get something from the hardware store, like Lowe's Hardware, and get and machine plumbing or irrigation parts with these MPT threads on them. They're readily available, and they're just as cheap as dirt. 50, 70 cents for this part, 70 cents, maybe $4 for that part, and I get 4 MPT threaded fittings out of it, cut a section of it off, and then I get the intermediate fuselage piece for 5.5, and plus 2 of these cut off either end, so a double-use part that only costs like $4.50 from Lowe's Home Improvement Centers. There you go. Budget build, works great. The gray stuff, I do want to warn you about. These aren't that heavy. This is a shower chair. Somebody has given me an old shower chair that you couldn't sound on. It wasn't structurally sound anymore. So I cut it up and I use these tubes. These are combination of female, male, MPT threaded irrigation parts. Then of course on this end, went on the end. Oh, look at this, man. The camera's so wide. This went on the end of this. In the middle of the tube here, I went to 99-cent store, which is right up and around the corner from where I live in Fullerton, right here, right now, what I'm talking to you about. And the tube itself is from a grabber with a metal boom. That's the tube itself. And I just put a little bit of I think I shimmed it with one roll of double-sided tape and then shimmed it again with some electrical tape and made it tight. I like these compound shimming procedures using double-sided tape, Harbor Freight, $2 a roll. They have that stuff in stock all day long, 365 days out of the year. If it's not a leap year, then they have it longer. And then the electrical tape. Guys, you can get electrical tape for $1 a roll. You can get electrical tape, you can get colored electrical tape. If you don't like black, get yellow, get white, get red, get green. They got blue. They have decorative electrical tape for all your emotional needs if you're an electrical designer, or like me, you want to build rockets. So if you want to see black electrical tape because you want to see how thick the shimming was for the black electrical tape and versus the thickness of the double-sided tape, you're going to run a compound shim. Well, then guess what? You can that black electrical tape will show up. It'll stand out in contrast to white PVC bodies, and of course the white colored double-sided tape. If you don't want to use double-sided tape from Harbor Freight, guys, you can get it anywhere. You can get it at Walmart, which is right in front of the Lowe's on Lemon. It's like Lemon Street and Orange Street. Okay, 3M works. Believe it or not, 3M. I'm not completely confident with the 3M's ability to make a product that lasts. I have more problems with 3M than I do with this generic no-name double-sided tape for $2 a roll, a half-inch thickness in Harbor Freight. However, 3M makes other products that are absolutely excellent. There's sandpaper for the block sanders, etc., etc. But I don't want to do lecture. I kind of want to do a little lecture in lab today, but this is what I wanted to show you. I got so anxious. I said this in the last episode. I did a lot of work on this. This is, I don't know if you can see the detail here, but, and I kind of, let me put this back on because we're done talking about that. This rocket is eventually going to launch and fly, and of course that's going to be part of the show. But, I need to somehow procure more funds. I'm hoping to get some funding from this channel so I can put it back into, actually setting up for actual real launch. I have other streams of income that I'm working on. They're legal. They're not illegal, fattening, or immoral. But anyway, I want to share with you. I don't know if it's kind of hard to see this stuff, but I use that clear silicone, which so far works okay. But the stuff, it literally takes about 5 days to really set up. Otherwise, it's kind of grainy and picky, and it's still kind of flaky that way. This is a clear silicone sealant. These are three tubes lined up. And you're going to have. Let me set this down for a second. I have to hold everything. When you have two round tubes together, you have that kind of rounded gap in between them, and these tubes, they tend to want to roll back and forth. Now, unless you have another way of fastening the tubes to the fuselage, that took me about a year to figure out how to do that, and it's taken me so far. It's taken me 5 years to figure out how to get to this point. We have a 3 fastener system for joining these tubes to this intermediate fuselage section in the middle, and that is, of course, the double-sided tape. However, because of the width of the double-sided tape would have gone up on the radius of these motor tubes too far, they would be too visible, and it wouldn't be sticking to anything. It just look unsightly. Guys, when you're building a rocket, you want something with a reasonably decent finish on it. It's not just a matter of taking pride in your work, but it's not really encouraging to launch something that looks scrappy and cheap. So you want to finish it. So, like I ran it long axis. I cut it in half. We demonstrated that in the last video. But the other thing was, so we line these things up. They have to be aligned with long axis of the rocket tube. That's the first motor tube. And then the second one it has to be lined up with the long axis of the tube. Not just the long axis, but it can't just, it has to adjust this way, and it has to adjust that way. When you install the second motor tube, it has to line up with the long axis of the tube, 1, 2, but it also has to line up evenly with the other motor tube, the case being, if you can take a look at this, and I still kind of goofed up a little bit, and I got these motor tubes on. Let me remove this. There's a lot of instruction involved. Guys, I've been doing this for 23 years. I love what I'm doing. I love rockets. But here's what's important about this. Practice makes perfect. But if you watch instructional videos like mine, you don't have to spend 23 years figuring things out. Depending on where you are in life, if you're young, yeah, you got the time. But if not, I used to build rockets when I was younger, and I didn't think anything of it. I got into rockets, and I discovered my love for it back in the year 2000, before 9/11, as a matter of fact, which was just an absolute national tragedy. That whole incident made my blood boil too. Ever since then, ever since I discovered my love for rockets, it's just been all uphill from there, and it's never ending. I'm so enthusiastic about rockets. I'm afraid that if I get into it too much, I'm not going to eat, sleep, or drink. I'm not going to do anything. I'm just going to work until I self-destruct, and that's not good. So I kind of probably need a girlfriend or a wife, but I'm not pitching one on the internet for that. I'll get that taken care of on my own. But you know what I mean. A nice girl to balance me out. But anyway, let's get back to this dead shot. Camera work is interesting in that it takes the three-dimensional image, it transmits it to a one-dimensional, one-sided media, and then tries to make it 3D again. So you're taking something true, creating a falsehood, and making it look true. It's a little too convoluted. That's why I don't like electronics that much. If they serve my purpose and they hold up, and they help me make money and help me share information with people who are sincere about sport rocketry as a recreation, and then moving on to sounding rockets, or even learning how to build micro launch vehicles, medium or large launch vehicles. I love that too. Nothing for destructive purposes, no weapons. Unfortunately, no military involvement. I'm proud of myself. I'm a Christian. I believe in self-defense. I appreciate my freedom, and I salute the servicemen and servicewomen of the armed forces, branches of the armed forces of the United States. And I celebrate Memorial Day because my father was a serviceman in the Navy during Vietnam. He served 2 tours. My grandfather was a Marine fighter pilot. I have nothing but respect for anybody and everybody who served in the Marines, the Navy, the Air Force, the Army, Armed National Guard, even Space Command, which I am excited about, and of course our Coast Guard. And you men and women, you put your asses on the line to protect me and my freedom and this country that we live in, this great country. So I appreciate that. I'm not going to build anything for the military. It's a violation of my conscience. I don't want to bring religion or politics into it. I just say that's what I am. I'm not a terrorist. I don't like violence. I don't like hitting people. I don't like arguing with people. I like a peaceful, quiet working environment. I like science and technology with a passion. Fighting in war and hurting other people has no part of my life. So anyway, so let's talk about this alignment issue. Lining these motor tubes for stable flight is what you want. When I'm talking about, and I should be writing this down. But see, this circle, the outer diameter of this upper motor tube assembly, with its male MPT fitting, the lower one, they're of a greater diameter than the intermediate or lower fuselage piece. So in a sense, you have 2 larger circles they need to be equidistant, attached to and aligned with the long axis of the smaller circle. The circles being the side end and the back end, or the side view of 3 tubes. 2 tubes, same size, larger than 1 tube, which is in the middle of the tube. Well, when you build rockets, they have to be asymmetrical if you want a stable, correct flight. So what is asymmetrical in that particular case? It is the imaginary center line running down the long axis of this tube, imaginary center line running down the axis of this tube, imaginary center line running down the axis of this tube. All three of those rest on the same imaginary plane that would go directly through the middle of this particular section of the lower part of the fuselage of the rocket we're building. Okay, all three of those lines, they need to be sitting flat from front to back, but they also need to be sitting flat front to back, all three at the very same plane. In other words, if you put another flat imaginary plane on top of them, or you put another flat imaginary plane on the other side, there won't be any wobbling or any gaps. Sort of like evening out pant legs on a table. You go to a restaurant, you have a four-legged table, all four legs need to be the same length. Of course, you can never get that, so they put adjusters on the bottom so that the four legs are the same length, so they're sitting on a flat plane, which is the ground, which is the floor of the restaurant, so the table doesn't wobble. It doesn't stop there because they can all be misaligned on a skew plane. A plane that's the floor is the true plane. The floor of a restaurant, according to building code, is a flat, true plane. 1, 2 axis, A and B axis. The floor of a restaurant, especially in Orange County, California, it has very, very strict building code. Foundation of any structure has to be dead even flat. Left, southwest corner, northeast corner, you need to be dead flat and even. You set a 2-axis level, laser level in the middle of the room on the floor of a restaurant that's being built. Guess what? The little sight bubbles, the little lasers are dead center. 2-axis dead center. The foundation sides are at a right angle with a true downward and horizontal position on whatever surface that foundation has been laid. That's construction 101. I mean, if you want to build houses and you want your cement, if you're a mason and you're laying foundation, I knew a guy, his name is Lance Castano, and that's all he did is laid foundations. He knows one thing to be true: that foundation has to be level. It can't be leaning to one side or the other. So he had to worry about two different axes, A and B axis. It had to be dead level flat on A axis, dead level flat on B axis. When it dried, you could set a stainless steel marble in the middle of that floor, and it wouldn't roll in either direction. It wouldn't favor one side of the floor or the other. It would stay in the middle because it wouldn't roll anywhere, because there wouldn't be any slant. There'd be zero slant on the A axis and B axis. That's very important. I'm going to be writing a book. It's called Right Angle Mechanics. I know it's a very, very presumptuous title. Forgive me, but a lot of what people don't understand is a lot of this math is basically like building a house with a bunch of toothpicks and popsicle sticks. When what you really need to know is a two-axis right angle plane of foundation, 3 axis right angle plane of laying the framework of the house. So if you want to build a level straight house like an American traditional 4-square, right angle mechanics always take over. It's a very, very, very basic form of geometry. In fact, it's so basic it'd be confusing to people who have done nothing but use computers and electronics their whole life. I understand the merits of some electronic devices, but hold on a second. But all things being equal, and they are not. At some point in time, I watched some YouTube channels where Jim was trying to, for lack of a better word, he's trying to diagnose a vehicle with a misfire under load. He doesn't understand anything like VTI, variable tension ignition. Well, GM has variable tension ignition. The GM's electronics division is very, very, very advanced. General Motors leads the automotive world in advanced automotive engine control electronics. And I respect them for that. But just using this as an illustration, the guy was doing this and this and that and trouble scanning and trying to consider things from a computer point of view. He had a $5,000, $10,000 trouble scanner, and he's trying to square waves and everything. And he's checking wave patterns and everything, and fuel pressure testing. And I got to tell the guy, he finally figured out that he's trying to hide his embarrassment, and the mechanics are kind of looking at him kind of funny, like, you spend a couple hours with all these electronics, use your head. As an experienced mechanic would know, there are a couple of things you need to worry about in the car: fuel, timing, compression. The other thing is vacuum leaks, physical vacuum leaks between the intake manifold and the combustion chamber, as well. How healthy are the spark plug wires? Because the truck he was working on had spark plug wires. There was a big old Chevy V8. Chevys after 1995 are notorious for extremely high tension ignition systems. They want those spark plugs to be firing under speed, under load. They know that the Chevy 350s, the Vortex, they're a workhorse engine. So Chevy engineers designed those systems to put out enough ignition to fire those cylinders, even if the engine was in the process of mechanically failing. Work until you die. That's their philosophy, and I respect them for that. But again, using this as an illustration, the guy working with all these electronics didn't understand, common sense. Work as a mechanic. When you're servicing a vehicle, you have maintenance intervals. Just change the spark plug wires, cap, and rotor. That's called an ignition, and not even an ignition tune-up. That's like an ignition overhaul. Check the timing. Check for vacuum leaks. Check to make sure that there's no cavitation in the fuel lines, because that'll occur under speed, under load, when the engine's working its hardest. But again, and instead of that, he's leaning on all these electronics. And again, I at one point I got the feeling that he was starting to feel embarrassed. He wasn't going back to the basics. He's leaning on thousands and thousands of dollars worth of electronics equipment to help him come up with a practical solution to a very real problem. He eventually got it fixed, but the roundabout way he did it, I'm almost thinking that he probably lost some viewers and a couple customers from that video because of the fact that he took so long and he charged so much. When a regular mechanic with a little horse sense come on and say, I need to review the service records of this vehicle. I've been working on GMs. I've been working on GM trucks probably since I was 15 years old. I'm 53 now. I can tell you with a certainty, the spark plug wires on a GM truck, they last 50,000 miles, and you got to replace them. The cap lasts a little bit longer. You got to replace it. I've seen ignition failures that pull a spark plug wire off the top of a post of a distributor. It's got all sorts of buildup on it. It's like it's not going to conduct electricity. So what I'm telling this guy, he lost viewers, he lost some customers because of this, because he did the roundabout, the electronic roundabout. I call it titty-sucking electronics. The reason I'm bringing all this up is mechanical common sense, physical touch, and eyeballing things and making sure you've got right angles correct will lead you down a path that will help you understand more quickly and more authoritatively and more confidently how to do things correctly. If you're heavily leaning on electronics to build your rocket, well, there's a certain cutoff point. You do need mathematical formulas to figure out its center of pressure. Center of gravity is a no-brainer. Leading edge of the first bottom third of any rocket vehicle, fully loaded. But when you calculate the center of pressure on a rocket, you need math. There are computer formulas, there are computer programs that actually help you do that. So that's where you need it. But and of course with a payload bay with electronically controlled flight cameras, accelerometers, barometers, altimeters, timing, things that when you have events that need to be timed, in other words, something that activates the recovery system, deploys the parachutes, that comes a certain amount of time after apogee, which is the high point of the coasting phase of the rocket launch, or the rocket flight. After that, 3, 4, 5 seconds delay, recovery of the rocket via the deployment of the recovery system, the parachutes, and the drogues. That is electronically controlled. That's where electronics come in. Electronic, computer programs, downloadable apps. You can download apps off Google Play that are free that'll help you calculate center of pressure and center of gravity. I referred the one individual to you, but I'll get you his name again. He's a young mathematician. He's probably about 28 years old. Real tall, skinny guy, very friendly and very enthusiastic. His name is Matt, but he's got a PhD in math, and he breaks it down succinctly. If you want to learn what's called the bucket and brush method, figuring out your center of pressure of your rocket vehicle, which is critical. It's one of the most critical calculations on a rocket vehicle, besides thrust to weight ratio, coefficient of drag, and total impulse, NM. which is burn time times pressure of the actual rocket motors themselves. Got more than one, you got to add that or multiply it by 2. Center of pressure, and if you've got center of pressure, that's the dynamic vertical balance of a rocket fuel as it's under flight, as it's under power. Okay, so if it's goofing up, then it's going to be a catastrophic failure. Not a CATO, which is CAT, or the catastrophic motor failure. That's just going to be a catastrophic failure of the rocket vehicle itself. If you want to spend a couple $100 on your rocket vehicle, you're going to lose a couple $100 if you don't do that calculation correctly. That's where electronics come in to help you with that. Timed events, altimeter, barometer, accelerometer, onboard camera, snapshots, when and what to look at, etc., timed event of deploying, lighting up a GPS to locate the rocket, smoke pot for smoke tracking of the descent of the rocket after the parachutes have come out, so you can actually see where it fell down. And again, electronics are involved. That is the importance of electronics. But what I'm denouncing is leaning on the concept of using electronics for everything. You're leaning on electronics too much. You're going to make things a lot harder for yourself. You're going to be learning a language that is going to lead you down a path that's going to make things 10 times more difficult and more protracted and frustrating. It's going to load you up with a lot of things, and you're going to get a lot of people involved in the project, and they're all going to be thinking the same way. And I got to tell you, it's going to be like 20 people making the same pot of soup that's based on a really bad recipe to begin with. I want you to learn by yourself. Then we can move into team sports. But I want people to learn by themselves how to do the basics without a computer. You need hands-on. You need to actually physically touch things. I have a friend. His name is Chris. He works for Boeing, or he worked for Boeing. He's a computer software analyst. He's a mathematician. He's a software analyst. But he got an education as an engineer. He's a really, really smart, successful individual, and I respect him. He works with software that determines when maintenance cycles need to take place on Boeing's commercial aircraft. Well, I can tell you right now, the way you really determine that is as a maintenance mechanic, either airframe or power plant. You actually look at and touch the vehicle, and you inspect the frame members, and by common sense, due to experience as an aircraft mechanic, either airframe or propulsion, the two main sectors of being an aircraft mechanic, the two branches you can be in. Just common sense alone is going to tell you that's only going to last so long. I was a master mechanic for 10 years, but I've been a mechanic on cars since I was 15, worked on cars for almost 34 years before I got out of it. And my hands have grown exponentially because of it. I'm a machinist and fabricator. I'm just a general mechanical engineer. Actually, I'm an industrial design engineer, but I can tell you the hands-on experience as an automotive mechanic told me a lot of things that engineers just don't know. If you don't work on the stuff you design, you're going to have the chasm of ignorance. You're going to be hiding behind computers. Computers won't tell you what practical experience getting oil on your hands and actually fixing what you design and build can tell you. So mechanics have the pole position, and experienced mechanics know more than engineers do, and they really do. So without the formal education. But I want my students, I want everybody watching this, I want you to figure out on your own with your head, your eyeballs, your hands, your mind, and your heart, etc., how to do this. Let's get back to this one basic principle, and I can even draw pictures, but I don't know how the hell I'm going to do that. Right here. We're at the 28-minute mark. Wow. Boy, time goes quickly. This is the smallest circle. This is a large circle, same size as this circle. You have 3 circles that are business end of 3 tubes that need to line up on the same plane. The imaginary long axis line needs to fall on the same dead flat plane. A flat plane that can be measured and executed dead level on 3 different axes, A, B, C, with right angle, with a true right angle ruler. Doesn't matter how big it is, something small and handheld. I'm just talking about abstract thought. This line here, and this tube here, this line here, and this tube, this line here, all the way down, front and back, they need to be dead level this way, dead level that way, and then this axis right here, this long axis, because this is a 2-engine rocket, this imaginary axis right here, this plane axis right here, vertical, straight up and down. You just set this on the ground and put a right angle level to it. Here's the thing. The imaginary long axis front to back line, here, and here, all need to be sitting dead, level, flat, no air gaps on that same imaginary vertical plane. Now you know you have the motors lined up. Now that's not just it. The business end, the bottom end, you need to line them up visually. But if you square cut these, they're true square cut. So in theory, a flat level needs to be sit without gap or angle on this flat level right here. So that's a dead angle. That is an absolute dead angle. So you have these set right. So you have these motor tubes set right this way and that way. This is a 2-engine rocket similar to the, I believe, the Titan. Unfortunately, the Titan, Thiokol didn't experiment with solid fuel motors that large. They just, again, they used computer models, said, okay, they set that thing up, and I believe it was the port engine, I mean, if you can even tell on a rocket, that the fuel grains, it's ammonium perchlorate, aluminum, a polymerized binder with oxygen, rust oxide as a burn rate modifier, for vacuum bagged and X-rayed for cracks. That's fine. The problem with solid fuel is it has only so much structural strength across the widest diameter, which in Morton Thiokol's case, they made the space shuttle boosters. Well, those boosters were actually smaller in diameter than the ones used on the Titan, I think. And the problem is, because those boosters on the Titan, or the Titan 6, were much, much wider, either they didn't index internal pressure with internal ablation, times throat diameter, times exit nozzle velocity, times total impulse, times space flight, times operating environment in a launch trajectory to get it into outer space. Well, one thing led to another, and it was too much for the internal grain on the port engine, and guess what? It segmented, turned into a bunch of charcoal briquettes. It disintegrated internally in the combustion chamber, plugged up the throat, built up pressure, turned into a grenade. Spectacular, $130 million failure. The whole rocket lost it. I mean, one booster blew up, the rest of the rocket is gone. Very, very, very good looking rocket, but the problem is, I believe, it wasn't the formulation of the fuel so much as it was the diameter of the fuel grains themselves. They could not hold up under that much of their own weight. So they need to reformulate the propellant. They need to reformulate the propellant itself, and somehow either install something in the tubes and the segments, type of webbing that's both vertical and horizontal support for the fuel grains, or somehow, some way, put layers of fuel grains, of long axis fuel grain segments in there to support the fuel grains, and cut their size in half. It'd make a faster burning rocket. So redo your calculations on the exit throat diameter and the design of the nozzles, but you won't have those spectacular explosions. I just think that propellant was too big for its own. It's just like setting up a wedding cake. The structural strength of the flour and the dough, the finished product. If you make a wedding cake too tall out of layers that are too thick, bread is only so strong. It can only support so much weight before it collapses on itself. I believe the fuel grains collapsed on itself because they couldn't support their own weight. It was too thick with no physical structural support, long axis of the grain. That's why that one blew up. And I'm sure they learned from their mistake, but as of yet, I have never seen another design like the Titan 6. And I'm thinking, to avoid that problem and avoid doing all the costly research and development, they just went to 4, 5, and 6 engine heavy payload rockets, which is just fine. It's another solution to the same problem. But if they wanted to stick with that 2-engine design on the Titan 6, if I'm saying if it's the Titan 6, if that's the correct name for it, then they need to reformulate and they need to redesign the internal grain segments to support the propellant so that it doesn't collapse on itself under its own weight. That was a solution to that problem. My gentleman I know, his name is Jerry Jackson. He's extremely intelligent. I'm acquaintances with him. Of course, I know his 2 sons and his daughter, Andrew and Alex. I'm very good friends with Alex Jackson. He's a really intellectual, very intelligent young man. He's about 20 years my junior. But it's interesting, knowing the Jackson family, I've come to learn one thing. They respect people who think straight and are logical. Now, Jerry Jackson is very intelligent. He worked for a company as public relations, and materials engineer and handler. And he's very intelligent. He says when he retires, he wants to build his own aircraft. I think he can do it. But he made a comment about that Titan 6 failure, that those very, very large solid fuel boosters, they had a twin nozzle liquid fuel booster in the central fuselage before the transition. And I thought that was kind of odd, but if you want to keep people who manufacture liquid rocket engines in business, I guess you can do that. I didn't think they should have. I think that was a mistake. But the biggest mistake, Jerry said it was the formulation of the propellant as well. And he said that's why it fragmented. It wasn't polymerized. It wasn't formulated properly. That was Jerry Jackson's observation, and I listened to him. The thing is, when something sounds right, or something is close to correct, or something is correct, it sticks with me. That conversation that's with Jerry Jackson stuck with me. And that's been like 20 or 30 years ago. The Titan 6 is a very, very old design. Gorgeous looking rocket. I'm sure they'd have telemetry and flight control issues with something like that. It's two boosters around a central radial axis. I mean, you have more control on one axis than you do the opposite one. Now everybody's going with multi-engine. The Indians in India, they go with 4-engine, good-looking rocket, four boosters. China go with 6 liquid fuel boosters. The Chinese launch vehicle is very interesting. I like it. I think it's a little impractical, but I like it. And then, of course, our own. All the other Deltas, not the Titan 6s, the Delta 6s, and of course Blue Origin. We got Blue Origin and SpaceX involved as well, and of course we got Rocket Lab, who they're Rocket Lab are designing launch vehicles, but they look like toy rockets. So I'm not really impressed with the designs of what they're coming out with, but like I said, the concept of this, of setting these motor tubes upright for a correct design. Long answer short, these all need to line up on the same axis, the same imaginary plane down the middle of this center one, because that's a fuselage piece with the launch slug in the middle of it. In relation to this being aligned long axis with this, of course, relatively speaking, you don't have to be absolutely anal retentive about it. These are low speed, low altitude rocket vehicles, all the same. If you're going to put this much work in a rocket, you absolutely positively want to make it work. So, all things being equal, this guy is not one I want to work on today. But I am going to do, oh my goodness, we're at the 37-minute mark. Please forgive me. I'm going to get a little bit of drink here. I got myself some iced coffee. It helps to be resourceful when you're low on cash. By the way, I wholeheartedly endorse 7-Eleven. 7-Eleven rewards program. Take your own cup. You can go inside, get ice, usually for free, but if not, if they're hard up for cash, they'll charge you 50 cents to fill up your own cup with ice. They've got great deals on coffee. I believe in the one shot of caffeine at the beginning of the day to get your mind woken up. I do believe that caffeine is sort of a kind of a natural supplement for your brain. I think that using it too much is like abusing alcohol or abusing sugar or eating too much food. You just get your one shot at the beginning of the day and it helps you out. It works in my case. I don't know how it works in yours. This is the first rocket we started with. And as you can see, I've attached the launch slug to this. I'm thinking I'm going to clean up the launch slug a little bit. I'm thinking I do have some clear silicone, and I'm going to put that in between those two gaps there. The appearance of smoothing out this area where you have two curves coming in an intersection with each other at this point is that curve in the middle that, I don't know, looks like the profile of a plant. The feathers grow, or the leaves grow outward. You kind of don't really want that. This is kind of a catch and grab area. It's going to cause a disruption of flow of the air. It's negotiable. These rockets only get up to, the small one like this will probably get up to maybe 150, 200 miles an hour. And if I want to get any altitude, it's going to be about roughly little under 2,000 feet. Where we're going to be launching this rocket, when we finish it, of course, is going to be Santa Fe Dam Recreational Area. And I'm going to read off the dates and times of those launches. I'm going to do that today. I'm promoting them as well. be nice to be paid for my promotions. By the way, I need to keep reminding you, hit the like, hit the subscribe button, leave a lot of comments. Guys, I need as many comments as I can get. If I'm doing something wrong, or if I'm screwing up somewhere, or if I'm a complete loser and I should get back into my boy band, then let me know in the comments section. I get anything and everything. Use profanity too. But one thing you can learn from criticism is what other people are doing, whatever people think you're doing is wrong, and you can use that to benefit yourself by correcting your course, doing things right. Because if you do things right, you benefit yourself. That's how I look at it. Okay, so in this particular gusset here, we're going to lay down the silicone. So that's what I have to do. This rocket is its max length. I square sanded both ends, but you know what? I'm absolutely annotated about that, but I might actually be seeing things. I just want to show you again how wonderfully this turned out. This is a standardized design at this point in time. I need to give credit, by the way, I didn't mention this in the last video. I need to give credit to an individual whose name I do not know, who's on YouTube. He has a YouTube channel. It has something to do with practical science. He doesn't always do rockets. I'm completely dedicated to rockets. Right now, sport and model rocketry is my forte. And that's what I want other people to discover is their own personal talents, maybe help them to understand themselves, something about themselves, and such and so forth. He's just more of a scientific channel, just broad physical science, and I respect that. But one episode he had is on how to build cheap rockets, build rockets very, very cheaply. And he showed this method of using MPT fittings to attach motors. This is a rebuildable motor system. This is off the legs of that shower stall chair that was going to collapse under its own weight. So I couldn't give it to anybody, so I just used the tubes. But here again, it's a male MPT thread right there, and it's a little bit too long. You shouldn't have things that long because you have to wind it in for a long time. And if you tighten it too much, then you're going to have a hard time getting it back out. MPT threads are tapered. They're made out of soft material. The tighter you run in, that's going to bounce back. And I've mentioned this before. They're going to decompress back and really hold up in the thread. And you're going to end up breaking something loose. And you're going to have to pull the female end out of the tube, which is going to create a disaster. You won't be able to launch because you're not going to be able to repair that type of damage on at a launch meet. It'll come with another rocket. You'll be able to launch that. But if you damage the female end, which is in the tube right here, you can see that black hole right there. If you damage that, then you're not going to be able to launch the rocket. That's what holds the motor in place and keeps it from shucking all the way through the tube of the rocket itself. You'll burn up the bottom section of the fuselage. You'll burn up the recovery system, the parachute, the cords. That will be a catastrophic failure. So if you have a failure like that because you've over-tightened the motor, you try to get it untightened to remove it to service the system, then yeah, guess what? You basically either throw the rocket away or you take it home. You very, very carefully repair it, and you let those the adhesives dry up. And you're very, very, very careful. And you don't do anything with that rocket until after you finish the repairs, carefully and meticulously, and then maybe a week or two later, if there's a launch, you can launch it at that launch, at that particular meet. But you do damage like that, no, you're not going to launch it at that meet. It's going to be a catastrophic failure. There's no such thing as adhesives like cyanoacrylate. It doesn't completely cure, even in a lot of sunlight, a lot of heat, 0% humidity. Even it doesn't cure for 24 hours. Some epoxies and some silicone fillers, they do not cure for a good 5 to 7 days. I mean, they say 24-hour dry time. Well, yeah, it's dry to the touch. Cure time could be up to 5 times longer. Anything you put together with epoxy, I don't recommend because it's expensive. It's difficult to eyeball the ratio of 50% catalyst to 50% binder of tree sap, which is the main material. It has a very poor handling time. You got to mix it on a plate. You got to mix it with a stick. You can't clean the stuff off with the mixing stick, and the plate you used it on, you can't clean that off. So you got to toss those, and you just metering 50%, the ratios and the mixing and the plates. It just sucks. Cyanoacrylate. If you prep the surfaces If you're doing it in hot sunshine, 0% humidity, cyanoacrylate is every bit as strong, if not stronger, than epoxy. I've said that before. However, under ideal circumstances, epoxy's upside is readily available, it's strong as hell, and you can glue it to anything and it'll hold up. Cyanoacrylate's not like that. It's very fussy. If you have so much as one speck of dust on your prepared surface that needs to be glued, and it's there, you have some type of debris or some type of contamination on the surface, needs to be glued, you use cyanoacrylate, and the conditions are just so much as 1% off, it's not going to adhere properly. The other thing is with cyanoacrylates, be careful. When the stuff dries, it gives off cyanide gas. So you cannot use accelerators with it in an enclosed area. That cyanide gas will attack most polymers and cause them to rapidly decompose and crack and shatter and become brittle and crack and shatter. In fact, accelerators for cyanoacrylates might be great for environmentalists who want to cause the decomposition of plastic to speed up, so that the plastic bags and milk containers aren't floating around in the ocean. Just a thought. Okay, so we've discussed that. I want to discuss the concept again. These MPT threads are too long. That's okay. It's too late now. I made this motor before I knew that. I marked the depth at which this motor would go in. Now I set the female end of this in. It was basically an irrigation fitting. The reason I set it in that far is because if I have it out here, a relatively high-powered rocket, the weight of this is going to be fighting against that joint. It's going to be fighting against this joint, and nothing's going to hold the rocket from wanting to toggle back and forth. Well, this is meant to hold it in, but if it's a stress point, yeah, it's going to break. This motor would be putting out about 120 Nm total impulse, which is an H motor. An H120 is somebody who has a level 1 certification like myself in NAR AAA. They have access to that type of motor. So with that total impulse and this being the joint, that's going to rock around it. This isn't meant as a long axis stress point. This is meant simply to secure this rocket, keep it from falling out the bottom of the rocket on the launch pad. Keep the motor in place, and that's it. So when we run this in here like that, in a tube like that, it's sunken in about this far, and I measured that. Okay, so that's great, but look at what we have. Now we have another problem. We have the gap between the inner sidewalls of this tube that are greater than the outer diameter of the motor tube itself. So what do? Well, there you go. We have to shim things up. Folks, I got to tell you, at some point in time, as professional as you want to be, you're going to have to resort to shimming things up. If you want to make bulkhead rings or bulkhead collars out of layers of fiberglass, more power to you. And I can show you how to do that. Phenolic rods, you can do that as well. However, guess what? If you're going to make a shim that's the same dimension as this black tape, okay, and because you really want to be professional, that's fine, but be prepared. You're going to have to set up a machine shop. You're going to need special machining equipment. I've done it before, and I got to tell you, it's a time-consuming headache. In fact, it's so difficult, it almost discouraged me from ever building rockets again. I found a cheaper, easier way. It doesn't add any weight because this doesn't require glue, and the weight of the electrical tape, first of all, you don't really see it, and the part you do see, it still looks professional. The weight is the same as a phenolic sleeve, craft paper sleeve, or even the apple green fiberglass sheets. Without the machining, you just overwrap this if it's too tight, and then you take some tape off and you get it till it fits snug. But what is the reason for the shim? The inner diameter of this tube is greater than the outer diameter of this tube. This particular section of the I only have two arms. This particular section of the rocket motor itself is housed securely in this tube. So this tube is a housing for this section of housing right there. It sets down there. So guess what? If this motor wants to toggle back and forth, it's pushing against the strength of this inner tube. This tube is the main fuselage piece of the rocket we're building. However, with that air gap, it can do the same thing. It can still allow the transfer of force, side-to-side force in the motor. Well, again, how do we fix that? Well, with the shims. This shim, the outer diameter of this shim, made out of what I cut and fabricated, have an even flat surface on the visible side. This is electrical tape. This shims up this surface so that the outer diameter of this surface is this side. The outer diameter of this tape matches the outer diameter or the inner diameter of this tube for the purpose of what? Press that down and run it in place. And by the way, the edge of this black tape is a mile marker for how tape should go in. But this tape is for what? Keeping this from wanting to wag its tail side to side. So now there's no more stress on that connectivity point. The MPT threaded two black nylon pieces of irrigation parts that you got from hardware or from Lowe's Hardware. 1, 2, 3, 4, 5, 6, all the way down the line. So one thing affects something else. So instead of spending 23 years by yourself learning rocket technology and going through failure after failure, because most of what I built in the past failed, I'm reasonably sure that the right calculations, the right construction methods, what I'm building now will work. And I know that kind of sounds bad, but the stuff that I built in the past, the stuff that did work, was very, very large-scale rockets. I'm talking rockets that were 10 feet tall, 4 inches in diameter. The smaller stuff tends to be tricky. My biggest problems were not calculating the center of pressure, and my other biggest problem was the fact that I used the wrong types of material that was too heavy and too soft, not suitable for aerospace use. So I've got that down. I've got motor design down. Now I have to figure out center of pressure. Again, the stuff I built that was large diameter, it was so big and heavy all the way through. The stuff flew great. And I even developed crude electronics for myself for a recovery system, and it worked fine. But I think some things happened in my life because I was running a bad business. I had some personal issues. I'm on medication for insomnia and depression. And I had some issues with the doctors putting on too much of one type of med, and I got in trouble. And I wasn't abusing drugs, but it did affect my ability to drive. I was running a mobile service business at the time, and it really kind of screwed my life up. I'm not blaming anybody for my problems, but I am saying, it was kind of a tragic period in my life. And of course, because of that, the rocketry got derailed a little bit. I was still building rockets, but on a semi-daily basis, and I was still learning stuff. But coming back into a full force, I'm thinking, first things first. So build something basic. I've been building a lot of very, very elaborate stuff. Some airframes I threw out because they're just too elaborate, and just the fastening methods I still haven't got down pat. Multi-engine rockets, the only one we're going to do is a twin-engine rocket. But see, you understand the concept of this motor system. So now I need to get phenolic sleeves, machine them down, it fit in that, and then we can show you how to load fuel grains. Lowe's Hardware has what you need. So does the corner grocery store. But I'm not going to get into that right now. I want to make sure the people I'm teaching are responsible and don't abuse the technology that I'm sharing with them. Anyway, so that is pretty much that. And I see that I did not reload these motors back into the proper housing. You hear the noise in the background. It is because I'm watching Lethal Weapon 2, Mel Gibson and Danny Glover. Of course, I believe Danny Glover has... Sidney Poitier? No, Danny Glover hasn't passed away. Sidney Poitier passed away. Danny Glover is unfortunately very, very, very aged right now. I don't feel sorry for him. I just wish everybody was young and beautiful. They can make a Lethal Weapon 5. Mel Gibson's got an name too. And so does Richard Donner, the director. So that's pretty much that. My word, we're at 53 minutes. Hey guys, I can't help myself. Each one of these sessions is going to be 53 minutes long. So today was pretty much all lecture. It wasn't lab. I'm not going to be doing machining and fabrication because it doesn't do any good to just watch some guy off in the distance playing around with tools and machining parts you don't know where they're going to go to. I want you to see the practical application of what it is that I'm teaching. And of course, we're going to be getting to the point where we're going to be launching these rockets. That's going to be really exciting. Hit the like, hit the subscribe button. I need comments. Also, my email is waca2023@yahoo.com. That's Wampler Advanced Commercial Aerospace 2023@yahoo.com. That's what WACA stands for. WAC as in Charlie, A 2023 at yahoo.com. Email me with comments and suggestions. My phone number, is something I'm going to withhold. I don't think that's appropriate for me to do that on a YouTube channel, so we're going to withhold that. But you have my email. I have another email. It's Jason David Wampler Armstrong at yahoo.com. That's Jason, then David, my last name Wampler, W-A-M as in Mary, P as in Paul, L-E-R, Armstrong, like strong arm, at yahoo.com. Those are my two emails. But like I said, you have my channel. Hit the like, hit the subscribe, leave a comment. I want to hear back from everybody and anybody who has the patience to watch these videos. I know it can be dry material. If I was sitting down, I'd end up putting myself to sleep. But you know, there's some technology involved in developing rockets. But once you know what you're doing, you spend enough time doing it, or you learn from other people who have experience, you can take the fast on-ramp on a freeway that somebody's been traveling for 100 miles, and you can get to the same destination within, like several hundred feet. So if you learn from other people's experience, and you learn from people like myself who teach you what to do and what mistakes to avoid. Those launch dates. This is important. I don't know if what I'm doing is unwanted promotion, but I do believe that Martin would appreciate me as a member of SCRA, which is the National Association of Rocketry chapter. I'm just trying to promote this. Oh, there you go. It's on this information page. This is sorry, you can hear my voice, but you couldn't see who was talking. Last page has those SCRA dates, and here we go. It's as follows. I keep forgetting. This is actually the image actually reverses. These are the dates right here. But if you can't read them, and I bet you can't, I'll just leave them there like that. And there you go. But I'm going to go ahead and read them to you anyway. SCRA launch dates. All launches start at 8 a.m. They go to 12 noon, and then between 12 and 1:30 is cleanup. Martin and myself would appreciate you. I'm a member who's, my membership has lapsed. Martin and friends would appreciate if you help, tearing things down. Poor Martin, he's there with his old Ford Escort station wagon. Some folks stay for about a half an hour. He's there till 1:30 in the afternoon. Takes an hour and a half to clean up the launch site. He's in charge. And you know what? If nobody else helps him, he does it by himself. And the poor guy, so stay afterwards and help him out. The launch sites, he says you don't have to be a member. You don't have to pay an event fee, but you do have to pay a park entrance fee. It is at Santa Fe Dam Recreational Area at the end of the off the 60 freeway. I believe in San Dimas, but I could not be absolutely sure about that. The Santa Fe Dam Recreational Area, you look it up. I believe it's a part of Los Angeles County. It'll give you an address and directions. If you got Google Maps, you can find it. But again, Martin's his name. SCRA is the Southern California Rocket Association. They're a chapter of NAR, National Association of Rocketry, and the events take place from 8 a.m. To noon, and then 1 to 1:30 is cleanup. That's voluntary, but you get extra gold stars if you help out. Park entrance fee, I'm not sure about. It's around $10. Could be as close to 10, 12 or 14. I don't know. Everything's expensive. Land's expensive. Don't be discouraged by the cost, because Martin informed me in his last newsletter he sent to my P.O. box in Costa Mesa that the events are free. Contributions are appreciated. You don't actually have to be an active member to be there and to attend and watch. But if you do launch, I think that you do have to be an active member of NAR, but I'm not sure. You might want to consider looking up SCRA online, Southern California Rocketry Association, that meets at Santa Fe Dam Recreational Area. Google them and figure out and read all the information you can to determine what the actual costs and requirements will be to go to these launches and actually launch something. If you're already a member of NAR, National Association of Rocketry, then you're a shoo-in. You just show up on time, you pay the park entrance fees, and of course there's an inspection, and you have to sign out a slip, and then you take a number, and then everything takes place orderly. Remember, we are dealing with rockets. Parameter limitations, so far as I know, single engine rockets only, anything up to G80. So there's no level 1, 2, or 3 certifications taking place, because this is like a family picnic area. It's not out in the desert wilderness. There are businesses and residences around a long distance away, so we can't launch anything really powerful. I believe the AGL waiver is around 3 or 4. I think the AGL waiver is around 3,000 feet. 3,000 feet max, single engine rocket max, G80 powered single engine rocket. It's a G80 powered motor max. So, but you can launch as many times as you can get your rocket to the pad. Usually a lot of people show up between 8 and 10 a.m., but by around 10:30, 11 a.m., you're down to like 4 or 5 people. And by the time noon is there, you only have like 10, maybe like 5 or 10 people there. Student groups show up, team launches. A lot of young girls show up there, which I'm really impressed. It really is encouraging to see, young women being an active part of aerospace and sport rocketry. Because I grew up where women had no interest in anything technological or scientific. That's kind of depressing. I'm an engineer, but I don't see any other engineers that are women, and I enjoy the company of women. I like to have some more women around enjoying the same things that I do. So come one, come all. Okay, so I'm going to get around to the dates. The dates are at Santa Fe Dam Recreational Area, 8 a.m. to 12 noon, all launch dates. April the 28th, which is, guess what? April the 28th is tomorrow. So today is the 27th, or is today the 28th? I don't know. Wait a minute. Wait. Hold on. Okay, today is Thursday. Okay, so April the 28th, what I believe is tomorrow, 8 a.m., 12 noon. I'm not going to be able to go. I have orientation and another job. I got a job at Amazon Fresh, so it's just part-time to support me financially while I do this. Then the next launch date is May the 8th. Then after that, June the 1st. No, excuse me, not June the 1st, June the 17th. July the 22nd. August the 5th. August the 26th, September the 9th, October the 21st, November the 4th, December the 2nd. All those events, Santa Fe Dam Recreational Area, part of, I believe, I'm almost positive it's part of the Los Angeles Parks and Recreation Department. All of them take place 8 a.m. to 12 noon. Santa Fe Dam Recreational Area, SCRA, Southern California Rocketry Association. Look them up on NAR, National Association of Rocketry. They're online. Look them up on Google and find SCRA. The chapter number, I don't know. It's been a while, and I actually lost my... no, I think I ended up throwing my card out because I didn't think I'd go back to the rocket launches, but I'm back in it. So I'll tell you more of my story in greater detail later. So that's pretty much that. My name is Jason Wampler. This has been a very, very long episode of the Rocket Minute. I've got to call it the Rocket Hour because I'm always shooting videos that are exactly, or not exactly, but mostly 1 hour long. So there's a lot of material to cover just for a basic rocket. It is rocket science, if you want to consider that. I'm a rocket designer. I'm a college dropout. I only have 35 units in industrial design engineering. But like I said, I've been designing and building my own rockets, including a few experimental scale aircraft, since the year 2053. Been doing it for 23 years. That plus rockets, 23 years. Been working on cars since I was 15 at 1985. So 15 plus 23 equals 38. Honest to goodness truth, I've been working on cars for 38 years. I know a thing or two about car mechanics. Not my passion, but I had to do it to make a living as well. That's my background. Okay, so the Rocket Minute, we're probably going to call it the Rocket Hour. I'm not kidding, I'm serious. My name is Jason Wampler. I've been your host. Hit the like, hit the subscribe, leave comments. You got my emails, yada, 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 etc., etc. You guys have a great day.